We want to prove this formula for the dimensions of SUN irreps. Here yt is a Young operator for the Young tableau T, and here in this formula the product is over all boxes in the Young tableau. J and K are the row and column indices, and H, J, K are the hook length of the boxes. We're going to introduce some abbreviations first. So let's denote the product of the hook length by this. By the way, all these quantities showing up here, they do not really depend on the tableau, but only on the diagram, only on the shape of T. So here the product of the hook length, the denominator, that's this, and for the numerator we're going to introduce this notation. We're going to write this as ft of n, so that's the product of these numbers here, n plus k minus j. The proof will be by induction in the number of boxes. So for one box, we just have the defining representation of SUN, and that has dimension n. And that's fine with the formula as well. Okay, and then for the induction step, we're going to prove the following. So let me write this down first. We're going to show that the trace of yt is equal to n plus p minus q. Now the hook length for some diagram, some tableau T prime, the hook length for T, and the trace of some diagram T prime. So now I should first explain what T prime and P and Q are. So here the YT, that's a tableau, let's say with n boxes. And this one here, the T prime, is a tableau with n minus 1 boxes. And we get this by removing the box with the highest number from T. Okay, and P and Q are the column and the row of the box which we removed. Column and row of the box, well, that's the box with the highest number, the number n. T is a standard tableau, highest number. In T. Now, when we have this blue formula here, then we're done. Because if we compare with the claim, I cannot make this visible at the same time. So let's copy the claim. So when we compare with this, if the formula holds for this smaller diagram here, then the T primes will cancel. Maybe I should write it like this. So this is ft of n, and this is the product of the hook length. So the T primes will cancel, and this here is just the missing factor if we compare this numerator here for the diagram T and for the diagram T prime. So this recursion formula here would do the job. And now we're gonna prove this recursion formula using birdtracks, which by now you know are fancy. And this formula which we're proving, this dimension formula here, this is old and well known. And the proof, we're going to use the birdtrack proof that's somewhat more recent. It's from this millennium. It's due to Elvang, Cvitanović, and Kennedy from 2005.